Thank you for coming to our public meeting on the PCE issue we're having at the South Y in Lake Tahoe. This is the second of the public meetings. We had the last one in February, and we're planning on having a third one when we complete our analysis of the field data that we've been acquiring. And Eva will talk about that in a little bit. In terms of the agenda tonight, we're going to do some introductions, quick overview, and if those of you who were here for the February meeting, that'll be mostly a repeat of information. Then we're going to have updates from the three water agencies. Then we're going to have an update from the Lahontan Regional Water Quality Control Board. Then we're going to talk about the pre-design information that's been gathered and the investigation that's been conducted and completed. And then next steps of that process, and that's the state grant-funded project we've talked about the last time. Then we'll take a break, and after the break we'll answer questions, and then what we're going to do is we're going to pass out cards. And so as you listen, if you come up with questions, think of questions, you can write them down on 3x5 cards. We'll collect them at the break, and we'll take the time necessary to answer those questions. So in terms of introductions, my name is Richard Solbrig. I'm the general manager at the South Tahoe Public Utility District. So I'll be just doing the introduction here for everybody. We have our expert panel behind me. Jennifer Lukens is the assistant manager at the Lukens Water Company. Rick Robillard is the water system manager for the Tahoe Keys. Ivo Bergson is the South Tahoe PUD's staff hydrogeologist. And Scott Ferguson is a supervising engineer with the Lahontan Water Control Board. And so before I get into the rest of it, what Jennifer will be doing is talking about the Lukens Water Company's responses and what they've been working on since February in terms of looking for money and responding to the PCE problem. Rick's going to talk about the same thing that the Tahoe Keys Water Company has been doing over that same period. Evo will talk about the grant process, how it's going, and then he will give you a brief lesson in hydrogeology in order to explain the field results that's coming out of the study. So pay good attention there, because it's important for you to have some basic of understanding of that topic so you can understand the results we're getting and the significance of them. And then Scott will talk about the Lahontan's process of their own investigation of the PCE contamination and their oversight of the responsible parties' work plan for talking about and finding out what their responsibility is and what their level of treatment is on site and determination of off-site contamination. So that's an important part of the discussion here tonight too. So just to remind you of why this topic is important for the community is this slide shows you that for the drinking water that the people in South Tahoe are served, that over 99% is groundwater. And of that groundwater that's served, 97% of it is served by the three water companies that are here tonight. There's some individual wells and some very small private systems for the remaining 3%. But looking at that, that's why it's so important, since we provide the groundwater. And let me make a statement that's a repetition of what you heard at the first meeting, is that the water that you're being served, that's coming out of your tap at home, meets all the drinking water standards. Just take that in so that we don't have to answer questions like, can I water my tomato plants in the backyard? Can I give this water to my pets, my children? The water meets drinking water standards from all three of the companies that are here tonight. Now, looking at the groundwater basin itself, we are in what's called the Tahoe Valley South Basin. And you can see Lake Tahoe is at the top of that map, and the blue line basically outlines the groundwater basin, which is deposits of materials erode over the thousands of years of erosion from the mountains and glacier outwash. So the the thing about that is it's very permeable soils for the most part, so it's very highly productive for the groundwater, and that's why you see all those little blue circles in there. That since the district was founded, and even before, as people settled in Tahoe, groundwater was the primary source of drinking water, but was very accessible. And if you think of that's not a three-dimensional map, but the surrounding mountains, the watershed, all that water from the top of the mountain that drains into the basin is recharged for that basin. So it's not only it's very highly productive, and there's a lot of water to be able to tap into of excellent water quality. What that has resulted in is very high reliance on the wells, and you can see the wells, they cluster around actually Highway 89 and Highway 50, and that's the commercial area. So because of their location, because of the permeability of the soils, the system is susceptible to contamination. Then that is what has happened in the South Y area. PCE has hit the ground and is perked into the groundwater, and all the wells are all in that same vicinity. So zeroing in on the area that we're talking about, the Y is right at the lower right of that circle. The circle, the dashed lines, is the known and estimated area of groundwater contamination as we know it today. The blue arrow is the direction of groundwater flow in general in that area. You can kind of see at the top the purple area with the blue fingers, that's the Tahoe Keys Water Company area. The green area is the Lukens Water Company area, and in the surrounding area is the South Tahoe Public Utility District. And the information on there, the one update to that map was shown the last meeting. The one update is that the data, the 2007 monitoring data, is now reflected in those circles. The red circles are, the bigger the circle, the higher the concentration of PCE that was found. And the red dots are the information that was gathered by the water companies, and then the I would call it pink, but it's probably mauve or something like that. Those orangey colors, that's data that has been collected by the responsible party. And if you notice, the highest concentration is where that red arrow is, and that's about 1/5 in Eloise. And right near there is where we actually punched the well that Evo, the sampling wells that Evo is going to describe in detail, later in the presentation. So that's where the maximum contamination has been found so far, and that's where our project has been located this summer for sampling. So just to give you an idea, the impairment has resulted in about 3.25 million gallons of water production on a daily basis, which is about 5,000 average California households. So it's been a significant reduction in the total water production, looking at all of our systems in general. And currently the PCE detections is 3 Lukens wells that have PCE detections, and there's 2 Tahoe Keys wells on that map if you look closely and follow the symbols. So that's our current situation. That what is in those dashed lines is approximately 400 acres. So with that, we'll turn it over to the first area expert, which is Jennifer Lukens.
Thank you, Richard, and thank you, everybody, for coming tonight. So after February, moving forward to April of 2018, Lukens Brothers Water Company was authorized and granted authority to start seeking funding for our treatment plant, our GAC treatment plant on well number 5. With that, we researched a number of different funding avenues via private loan, public funding, responsible party funding, and currently we are working with the Division of Drinking Water at the State Water Resources Control Board and pursuing state revolving funding for this project. It's a slow process, but we are navigating through it. In June 2018, we did 2 separate samplings at well number 5. came back with results of 58 parts per billion and 60 parts per billion for PCE, and 1.3 part per billion and 1.4 part per billion for TCE. Eva will get into more detail as to what that means for the plume and what that means for our next steps. The filtration system project plans and specifications, which were grant funded, have been submitted to the Division of Financial Assistance and Division of Drinking Water for final review and comments. Once those comments are received, we'll update plans per their request, and then the next step with the state is to go into final budgetary review and contract development. So as soon as the funding and the contracts are issued, we'll put the project out to bid, regardless on if it's in the spring or in the winter, just because of the lead time it is for the treatment vessels. In August, and currently, we continue to work with the local, regional, state agencies to move forward on funding our projects. We're awaiting direction from the Water Board. That's Lahontan, who is the primary agency in charge of investigating and enforcement on the responsible parties. So we're awaiting direction from them on that in order to determine what our legal action will be from there. We're engaging in getting our public, our customers, the community involved in this investigation and in the cleanup process to raise awareness about third-party water contamination, how to prevent contamination, how to spot contamination. These are all public engagement processes we are starting to work on. And then 2019 is our anticipated construction of the GAC filtration system. Our next steps. Right now, Lukens has submitted an application for a feasibility study to the State Revolving Fund to determine new water sources within our water system for the future. So that application is in review at the state. As soon as it's approved, we'll put it out to bid and begin that feasibility study. Yes?
Has Cabot Norit been included in the GAC sense? Granulated activated carbon function, Cabot Norit?
Is that a specific company?
Yes, it is. It's the only company in the world.
It hasn't gone out to bid, so everything is, the state requires that everything be an and or equal. So it was designed by the engineers, and so they don't name a specific company. So when it goes out to bid, they'll probably pick it up and bid it. Okay. So I'll turn it over to Rick with Tahoe Keys.
Good evening, everyone. As mentioned earlier, my name is Rick Robillard, and I'm the Tahoe Keys Water Company Manager, and my presentation will be pretty quick, but I just kind of want to give a quick update between February and now, what the Tahoe Keys Water Company is currently doing and what we're future looking at to address the PCE concerns within the Tahoe Keys Water Company. So for those that aren't familiar with the Tahoe Keys Water Company well number 2 operates a granular activated carbon filtration system to remove the PCE. For those that aren't familiar with the granular activated carbon, imagine 2 big giant Britas. The water pumps in, comes out, removes the PCE, and sends it to distribution system. So we continue to monitor the well number 1 for PCE. That was the one that had detection limits. We are still below the state maximum contamination level, known as the MCL, 5 parts per billion, and that's running within the 2 parts per billion section. So we're looking in the fall of performing what's called water quality monitoring within our well number 2. The well itself, imagine a big giant straw down into the ground, and in several parts of the straw there's where the water can come in. So we're trying to determine at what vertical extent or elevation the PCE is coming in for a potential well modification or other aspects within the engineering to gather more data. And then what are we going to do with the next steps? So utilizing the DRI, Desert Research Institute groundwater model, which is be able to model the PCE plume and concentrations and kind of where it is within the aquifers. We'll look at within the Tahoe Key service area and potentially outside the service area where we could put a new replacement well to replace well number 1. Evo is going to talk a little bit more about the groundwater model as part of the feasibility study, so it'll kind of give you a little more background on how we would utilize that. So, and that's it. Right.
Okay. Hello, everybody. My name is Ivo Bergson. I'm a hydrogeologist with South Tahoe Public Utility District. So for our update, since the last, or our first public meeting in February, there was a big effort at that time. The grant, we were negotiating a grant, and so we finally executed the grant. We worked out as far as the conditions and scope of work for a Proposition 1 groundwater planning grant. That was completed at the end of April of 2018. The grant fund award was a little over $500,000. That's on a 50% cost share basis. And so work that we did in 2015 and 2016 as part of the investigation of this problem, we leveraged as our cost share on that. So that's how we covered half that amount. So for that grant, and after we got the paperwork done and signed off for that groundwater grant program, or for the grant, we went and we actually started work on the work plan for the pre-design investigation before the agreement was executed. And we actually got approval on the work plan for the pre-design investigation before April 29th. And so we were all ready to move forward with the pre-design investigation. After Lahontan's update, I'll talk a lot more in detail about that pre-design investigation, so I won't spend any more time on that. And then one of the other efforts that we've done as part of the conditions of the grant agreement is to develop or convene a technical advisory committee, and that includes members of the oversight regulatory agencies, so that would be the State Water Board, Lahontan Regional Water Quality Control Board. And we also added the water purveyors, so we have Lucan Brothers, Tahoe Keys, as well as membership from the City of South Lake Tahoe, because all these groups are important, getting their input, because the work that we're looking at to do under the feasibility study has to be in coordination with the work that's being done by Lucan Brothers and Tahoe Keys at their source wells.
Good evening, everyone. My name is Scott Ferguson. I'm a division manager with the Lahontan Water Quality Control Board. I also have here on our staff Jeff Brooks, who's our unit supervisor of our site cleanup and enforcement unit, and also Brian Gray, one of our engineering geologists that's working on this project. He's also with the site cleanup and enforcement unit. I want to thank you for all coming out tonight, taking time out of your busy schedules. Your participation in this whole effort is very valuable. There we go. Real briefly, this evening I want to share just who our agency is, what we do, and more importantly, what our involvement is with the South Y PCE contamination. Real quickly about who the Lahontan Regional Water Quality Control Board is. We are a California state agency, and we're responsible for protecting and restoring groundwater quality, both in surface waters and groundwaters within our region. Our region covers basically the eastern side of California. More specifically, it covers the area east of the Sierra Crest from the Oregon border all the way down through the Owens Valley and into the Mojave Desert in Southern California. And our board our agency is made up of a 7-member board appointed by the governor, and then it is supported by technical and administrative staff. The way we go about our business and striving to meet our responsibilities is through a combination of permitting, project review, inspections. We also do monitoring, we do planning, and we also do site cleanup oversight and also enforcement. And you'll hear a little more about that in a moment. So that's who we are, where we are, and kind of how we go about our business. More specifically, with the South Y PCE contamination, our involvement there is on multiple fronts. Right now, you've heard reference to enforcement actions against responsible parties. What that's referring to is the Water Board has issued a cleanup and abatement order for the Lake Tahoe Laundry Works site, which is part of the Rayleigh Shopping Center at the Y. It is known to have contamination at the site, and as part of that cleanup and abatement order, the responsible parties are required to continue investigating and expand their investigation out to determine how far and how deep their contamination emanating from their site has traveled. They have submitted a work plan, multiple versions of a work plan, and we're preparing to approve that work plan and get them out into the field and start that additional investigation. And hopefully within the next week or so, that approval letter will be out. We're also looking for additional sources and responsible parties that are involved with this contamination. We've done some investigation in the past, or overseen some investigation. There's more investigation going on. And if we do find additional sources and responsible parties, they too will be brought into the process of investigating and then following up on remediation and mitigating the impacts of this contamination. We're also working with the State Water Resources Control Board, which is our parent agency, to secure additional funding to do more regional investigation. So as was shown up on an earlier slide, it showed approximately a 400-acre area is being affected. That's based on information on a variety of different, more site-specific investigations. We're looking at doing an entire, what I'll call, snapshot investigation to fully delineate the extent of the plume, both laterally and at depth. We're also looking to collect information or put in monitoring equipment that will assist the water districts in some of their efforts to respond to this contamination, both in management of their systems and then in planning for future systems or treatment systems. And then also we are continuing to coordinate with the water districts, the city, responsible parties, and you, the public. That's ongoing. We were here at the last public meeting, part of the Q&A. We're now explaining more of what our role is and responsibilities are here. We're looking to improve the information sharing and coordination among the multiple parties that are involved with this, so that we can get to a solution as quickly as possible. Moving forward, we have plans to increase really our coordination with the water districts and the public, and focusing with the water districts. One of our primary focuses, as you've already heard, is funding as a critical element of this whole situation. And we will be looking to put our resources in, our time and effort, to help facilitate securing outside funding. And our primary sources would be with the state of California to help with funding water supply protection, treatment, and future development. We're also focusing on the planning and preparation that it takes to continue, have the water districts continue providing a safe water supply. That is our number one priority at our agency, and we are doing everything that we can to help our partners with the water district, the city, to make progress towards that and maintain that safe water supply that they continue to provide. With the public, we're looking to continue and improve our communication with you. Working with factual information is critical, and in this, water supply is very near and dear to everyone's hearts, and it's important that you guys be kept up to date on what is progressing, what is being done on the front to keep that water supply safe, and to know that you continue to have a safe water supply. And that's all I have at this point. Thank you.
Okay, before I get into the pre-design investigation, can I just ask how many consultants are out in the audience? Just raise your hands. Okay.
Consultants?
Consultants.
What kind of consultants?
Groundwater consultants, engineering consultants.
I'm a physicist, but
Well, you can raise your hand. Okay, well, that gives me an idea as to how much I need to get into terms and such. So the pre-design investigation, the pre-design investigation, initially when we went in and we submitted our technical proposal to the State Water Board, this was not included. So during the negotiations on the scope of work, the State Water Board strongly recommended that the district go out and actually collect some field data that could be used by the engineers in the feasibility study. And actually, we thought that was a good idea, and we thought as far as, well, what would be the best approach? I mean, they were looking at, why don't you install some monitoring wells? And we thought, well, that really is not going to get us a whole lot. And so we formulated this work plan for the pre-design investigation, where we decided to go out and identify a site that was appropriately located within the groundwater plume, where we can maximize the amount of information that we could get through our field investigation. Drill a test hole, drill some test wells, and then design the test wells in a manner where they potentially could be used as what we call cutoff wells. So these would be shallow extraction wells to contain the plume in the area where the largest amount of contaminant mass is concentrated within that large 400-acre area. And then we also, as part of that, after the test wells were installed, we do aquifer tests. And the aquifer tests are done to collect engineering information about not just the permeability, but the transmitting properties of the different water-bearing zones that through which the contaminant plume is moving. So that's pretty much what the objectives are and what the process was, and you can see the dates of what we did for the pre-design investigation. So the first step that we did as part of this groundwater investigation was that we collected groundwater samples. I'm not sure. Does this have a pointer on it? I'm going to go to the screen. So the pre-design investigation is the site.
You need to have the mic by you for the live stream.
What's that?
You need to have the mic by you for the live stream.
Are you losing me? Do you need me to talk?
I can't hear you on the live.
Oh, I'm sorry. Okay, well, down in the lower right, you see that large arrow, that red arrow there. That's pointing to the field location for the pre-design investigation. Those kind of red marked dots are locations of existing monitoring wells. And on the table are the results of the sampling results of the groundwater samples which we collected from those particular wells. So the MW4 set of wells, you can see that it's a well cluster, and there are 3 wells in that well cluster, and each of the wells in that well cluster are screened at different depths. So you have the A well at 15 to 25, the B well 35 to 50, and the C well at 59 to 79 feet below ground surface. So if you collect samples from each of those wells, you can see what the vertical distribution is of the contamination at that point. Now, if you look a little bit to the west of where the arrow is pointing, there is another cluster of wells, and that's the MW10 well and the EW4 well. So those were located about approximately 500 to 700 feet west of where the pre-design investigation was located. And you could see that the monitoring wells in that area, the MW10 wells, have similar depths as the MW4 wells. And one of the, I think, important findings is that we actually did not detect any groundwater contamination in those wells. So that suggests that the plume may actually have more of a linear type alignment as far as there may be fingering that's going on in that plume that is not picked up by the general representation, the general shape of the whole area of the groundwater contamination. If you go now, the MW7 wells, those wells are located north with respect to the field investigation. So you remember you saw that arrow, and the direction of groundwater flow was to the north. So that MW7 well is located down gradient with respect to the field location as well as the neighboring monitoring wells. And if you look at the results there, there was low levels of PCE contamination in the 70 to 80 foot interval, but there was a deeper well at 120 to 140 feet where you had relatively high levels of contamination above drinking water standards at 14 parts per billion. Now, what I did on this table is I supplemented the sampling data that we collected during the baseline sampling with sampling data that was recently collected at the Lucan Brothers and Tahoe Keys wells. And you could see the Lucan Brothers well sample. That was the number 1 well off to the far left. That well was sampled in March of 2018. At that point in time, it was still non-detect, which is a good thing. However, the number 5 well, which is marked in yellow because it's an inactive well, that well was pumped and purged of 20,000 gallons before a sample was collected. And there were actually 2 samples that were collected, and there were 60 parts per billion. So those are the highest levels of PCE contamination that we have identified in those wells. And we've been collecting the current data, doing sampling through 2016, 2017, and now in 2018 it stepped up to 60 parts per billion. The Tahoe Keys wells, the sample results were fairly consistent with what was found in 2016 and 2017, where you had high concentrations of 24 parts per billion in the Tahoe Keys number 2 well. Again, that's operated, but it's operated because it has a wellhead treatment system on it. And the number 3 well, which again is to the far left in the Tahoe Keys service area, was non-detect. What I also show in that table are concentrations of TCE. Now, TCE is trichloroethylene, PCE is tetrachloroethylene. The difference between the two, or TCE, is a degradation product of PCE. So that is telling you something. I mean, this plume has been in existence for a long number of years, more than 30 years, and so that's where we believe the TCE is coming from. So again, this is just to put you in the context, in the broader context of the PCE distribution at the time of the pre-design investigation. So here's the site. It was 9 LOEs. The field site selected was on City of South Lake Tahoe property at 953 Eloise Avenue, which is at pretty much catty corner to the intersection of 5th Street and Eloise, which is right here. And so if you go and take a look at the inset there in the lower left, again, you can see the concentration map, and the highest concentrations of PCE contamination are up gradient with respect to the site. The arrow points, it's showing the location of the test wells. They're located about 80 feet north of that intersection of 5th Street and Eloise. You can see the white vessels that you see there. Those are granulated activated carbon vessels that were used for removing PCE from the groundwater, from the water that was generated during the investigation. Other thing to note is that the city property is also the home of the city's Eloise stormwater retention basin. So there's a large surface water impoundment of water next to the test site. So here is, again, to put in context for the findings of the pre-design investigation. Here's a cross-section that was developed by Lahontan staff, specifically Lisa Dernbach from the regional board. And this is from 2016 data. What it shows is the vertical distribution of contamination, of PCE contamination. And what I did was I projected in the location of the test hole at the pre-design investigation site, the field site at 953 Eloise. MW4 is that MW4 set of wells that we saw in the baseline sampling, and what this cross-section shows is that the contamination at the field investigation site is contamination that migrated in. So it migrated in with the movement of groundwater in this contaminant plume, and the highest concentrations within the contaminant plume at the pre-design investigation site was found at depths in the mid-zone interval, and that screen interval is about 35 to 50 feet below ground surface. And from the 2016 data, the levels of contamination were on the order of over 100 parts per billion beneath the PDI field investigation field site. Another thing to note is that if you go, this A would represent south, so that would be the area of the Y, right near the intersection of the Y, or immediately south of that. And then as you go to A prime, you're moving north. So north of MW4 and the test site, you can see that Lisa shows that the contaminant plume appears to be diving deeper into the aquifer. So that's kind of the background as far as what we had as far as for information and what to expect doing the investigation. So during the test hole drilling, one of the primary things that we do is we collect samples. We collect soil samples, and we describe those samples to generate a log, a detailed log of all the materials that are penetrated through that test hole. Now, we drill the test hole to a total depth of 150 feet. And what I'm showing is just for better resolution, I'm showing you just the upper 130 feet of that borehole log. And what you have over that 150 feet is a sequence of several, which we refer to as water-bearing zones, composed of sand. And these intervals are broken up by what we refer to as aquitards. So aquitards are important because these are zones of lower permeability, and these zones of lower permeability impede the vertical movement of groundwater. Okay, so they almost act as far as channels for that movement of groundwater to move within those water-bearing zones. And they're on the far left of this slide. You can see pictures of the core of those aquatards. Now, the most impressive of the aquatards, which I refer to as a major aquatard, there was a 6-foot section of this clay. And I'm not sure if you can see that in the photograph, but there are very thin bands in that clay. And those bands are what geologists refer to as varves. And varves are indicative of deposition in a glacial lake setting. And it's showing seasonal changes of deposition during times where there is water flowing and you're bringing sediment into the lake, and this being Lake Tahoe. You have deposition of those finer bands. So those are silts. And then when there is no runoff entering into the lake, you have deposition of the suspended sediments that are in within the water column, and that's the clay material, and that's how you get that varve banding in there. So there's a substantial section of that clay. Now, this is not the only place that they find this clay. This clay has been found in borings drilled throughout the Tahoe Basin. They've actually, researchers at UC Davis have actually dated this clay, and the top of the clay interval was dated at about 14,000 years before present, and the bottom of the clay is like 25,000 years before present, radiocarbon dates on that, and so that represents about 10,000 years of deposition. And what that represents is what's referred to as a high stand. So back, again, during the Pleistocene, or just before the Pleistocene, one of the last ice ages, it's inferred that there were high stands that were formed. There was glaciers that basically blocked the path of the lower Truckee River, and that backed up the water into Lake Tahoe, which raised the lake level and formed what is referred to as a high stand. And so the position of the shoreline of Lake Tahoe shifted to the south, okay, as it raised up in water level. And so you change the deposition from more of a sand environment that's closer to the alluvium that's being shed off the mountain front to something that's more characteristic of deep water deposition in a lake environment. So that's a very important horizon. Now, above that are two other aquatards, and these are more minor local aquatards that subdivide that log into 4 water-bearing zones, which we refer to as Zone A, Zone B, Zone C, and Zone D, and you can see the approximate depth intervals for those water-bearing zones. Now, to the right of the borehole log are concentrations of water samples that were collected during drilling, and these are zone tests. And zone tests are samples that are collected from specific depth intervals. And so we designed our zone tests, again, to collect a sample from the B zone and the C zone, and also from the D zone. And so we could get samples above that major aquatard and below it. And so I'm not sure what the resolution is to you on the concentration column, but what I'm showing the far left is PCE, TCE, and then we also had a large hit of benzene in one of the samples in the C zone. Now, if you take a look at the distribution of the PCE, I shaded the area where the majority of the contamination that's migrating through the groundwater system is flowing through. Okay, so where it's shaded or where it's kind of a lighter color shade is what is referred, many people call them preferential pathways. So this is actually the preferential pathway for the horizontal movement of that PCE contamination, and it seems to be occurring between depths of 26 to 38 feet. You had PCE concentrations above 30 parts per billion. And then the highest concentrations were in this lower zone beneath that from 40 to about 52 feet, where the concentrations were on the order of 66 parts per billion. And again, the TCE, the numbers are lower, and again, those are degradation byproducts of PCE. What you see on the far right of the log are schematics that show the construction of the test wells that were installed at the site that would be used for aquifer testing. And then also the way that the wells are constructed, the portion of that well, the upper part is the casing. Here's the casing. That's the screen interval. Okay, so that's where that well is drawing water from. And the screen intervals are set so that the water that is pumped out of that well comes specifically from a desired depth interval. So if these are used as extraction wells, again, the water that would be produced by those wells would be contaminated water. That's what we want to do, is gather up as much contamination with producing as little water as possible. So now I'm going to start just summarizing some of the initial findings, and after this slide we'll go into some of the aquifer properties that we defined during the aquifer test. So in the baseline sampling, to review, again, PCE was not detected in samples from monitoring wells that were located west of the field site. That was the MW10 and EW4 wells. There were detections in samples that were located north of the site. So it's consistent with that cross-section that you saw that Lisa developed that shows the plume is descending as it's moving to the north. What we have, hydrogeologists refer to that layering that you saw or we went through in the borehole log. It's a multi-layered aquifer system. So there are minor aquitards that separate that upper water-bearing zone into three zones, and we have that major aquitard that occurs at 94 to 100 feet. PCE contamination above drinking water standards occurs again through that zone B and upper part of zone C. There was no PCE detected below that major aquitard. However, there were trace levels of that TCE degradation product. So that suggests that, yes, PCE was there at some point in time, but now it was at such low concentrations that it's no longer detected, and it's changed and degraded to TCE. So that's its fingerprint that's left there in that lower aquifer, or lower portion of the aquifer below that regional aquitard. And that major aquitard, with the baseline sampling and the recent sampling, shows that the area north of that field investigation site, something's happening to that aquitard as far as why it's not forming a continuous horizon all the way to the Tahoe Keys wells. So there are holes, or a hole through that aquitard that is allowing that contamination to get into deeper portions of the groundwater system. Okay, so now we get into the initial findings of the aquifer testing. So this is why I asked the question as far as consultants. There are some terms that we're going to need to go through so you have some better understanding for these numbers that are shown in the table to the left. The first term that we need to talk about is hydraulic conductivity. Hydraulic conductivity is a term that describes the capability or the capacity of the materials, these porous materials, to transmit water. Okay, so we're just looking at, again, what the permeability to water moving through those materials is relative to each other. So there's hydraulic conductivity, and then on top of that, transmissivity would just be, you have hydraulic conductivity as the property of the material, and if you multiply that conductivity times the thickness of the water-bearing zone, the saturated thickness, so that's the thickness where all the pores are filled with water, times that hydraulic conductivity, that's the transmissivity of the aquifer. So that is the amount of water that an aquifer is able to transmit across what we refer to as a unit width of aquifer thickness. We don't need to talk about storativity too much. Seepage velocity is important because we can use the findings from the aquifer test to derive this number, and the velocity, and that is the actual velocity of the movement of groundwater through those different water-bearing zones. And so the seepage velocity is the actual velocity of water that's moving between the pores within those sand water-bearing zones. So you can see in the parameter table I show, or from the results of the aquifer testing, you see that the upper zone, again, you had lower levels of contamination. They were at 30 parts per billion, had a much higher transmissivity than the lower zone, which had higher levels of contamination. You can see that the seepage velocities also of that contamination moving through that upper zone are somewhere on the order of magnitude higher than the rate at which the contamination is moving through through that lower zone of where the contamination is found. With the findings from the aquifer testing, you can also use those results to calculate what you'll refer to as capture zones, and that's shown on the diagram, the two diagrams on the right-hand side. The upper one is the capture zone for the shallow test well, or if that was converted to an extraction well. During the aquifer testing, the responses that we got from that well look like you could probably pump that well at a sustained rate of 20 gallons per minute. So if you pump that well at 20 gallons per minute, then the area that it would be affecting as far as contributing recharge into that well, so it would be drawing water from the area within the inside of that parabola, okay, that inverted parabola, and the dot in the middle would be the location of the well. Groundwater flow direction is to the north. The parabola is pointing to the south with respect to the well. So the width of that capture zone at 20 gallons per minute is somewhere on the order of 200 feet. For the lower zone in zone C, you have a capture width. That well you could pump, or that well we actually did use as a test well, and during the constant rate test, we pumped that for 48 hours straight at 40 gallons per minute without any problems. And the capture width of that well is on the order of 600 feet in the upgradient direction, which is important because that means that that's the chunk of that contaminant plume that we're able to draw in to those wells and remove and take out of the groundwater system. So one of the last findings during the constant rate test, or part of the aquifer testing, we collected a number of samples at different times during the test. And on the left-hand axis, this is a log-log graph. You see contaminant concentration on the left. And for the different types of contaminants that are within that contaminant plume that we detected, you could see with the blue squares is PCE. Degradation product, PCE, TCE is in the dark bluish diamonds, and then another degradation product, DCE, is in the kind of light green triangles. And so what we did was we collected samples at 60 minutes. So at 1 hour, we collected a sample after 12 hours of pumping. So that's 720 minutes, and then we collected a sample after 24 hours of pumping at 1,440 minutes, and at the end of the test, 48 hours of pumping at 2,880 minutes. And so those are the levels of contamination that was found in those wells, in those samples collected during the course of that test. And you can see that they're relatively consistent. They're relatively stable over that 48-hour pumping period. Using the average concentrations from those samples for those different contaminants, you can multiply, if you have to change the concentrations into proper concentrations, or into you convert them into milligram per liter values from micrograms per liter. You can multiply the rate. You convert the gallons per minute to liters per day, and then you can calculate the pounds per day that you're actually producing from pumping those wells. And so from pumping the deeper well, where the higher levels of contamination, the extraction rate, the mass extraction rate of the contamination for the PCE is on the order of 0.03 of a pound per day. So it would take 100 days to gather 3 pounds of PCE groundwater contamination out of the aquifer. Okay, and that's because, again, you're dealing with contaminant concentrations that are on the order of parts per billion. So they're very, very small concentrations. So this information is being incorporated into the Fate and Transport groundwater model that was developed by DRI, and it'll also be used by the engineers during engineering design during the feasibility study. So that gets me into the next steps. So what are we going to do next? So between now and probably sometime into the fall, when we plan on having the next meeting, for the pre-design investigation, we need to complete the data analysis and prepare a technical report. That will be, after we have that completed, that'll be posted on the district's website. The groundwater modeling, the groundwater model, the Fate and Transport model, again, was developed by the Desert Research Institute. And we're in the process right now of performing preliminary runs for the remedial alternative simulations. What the groundwater model will allow us to do is model the movement and distribution of contaminants, and see how different approaches to cleaning up this site, to help us with the engineering evaluation to find the most cost-effective, most efficient means of managing this problem. So one of the simulations that we're going to need to look at is a no-action alternative. So basically, if we just status quo, we didn't move forward and did any additional groundwater cleanup, where would that contaminant plume go? How high would the levels of concentrations be in these in the drinking water, in the downgradient drinking water wells that have already been identified within the plume, and then also for those wells that are outside the plume, the neighboring plume that are neighboring the plume that are currently non-detect. So that's important information for us. We're looking at different scenarios, again, for mid-plume containment. So that, again, could be with cutoff wells, or it may involve something which is referred to as in situ remediation. So that would be possibly injection of chemicals to destroy the PCE contamination in place by chemical oxidation. And so with that occurring, how much of the contamination can we knock down in the mid-plume area so it doesn't become a contaminant load that needs to be treated at the source well. And then we need to run models where we do not do any work in the mid-plume area to compare that if it was just treatment by wellhead treatment at the source wells, to kind of gauge what the benefit would be. And so all that will, the results from the modeling analysis then will be provided to the engineers, and then the engineers will apply their engineering criteria outside of the hydraulic modeling that is done through the groundwater model, and get down to the to brass tacks, dollars and cents, to pencil out which is the most economical and most efficient method to provide a recommended remedial alternative for implementation to move forward with this project. So, thank you for your patience, and we're going to take a 10-minute break, and then you can use that time to prepare your questions, or if you have questions prepared, submit them to us, and then we'll be happy to discuss those after the break. Thank you.
So they'll talk amongst each other and figure out the right person to answer your question. Not all will for sure be answered, but to give you an idea. If you come up with any more as we're going, I'm gonna try to first address all the questions that were written down, and if we still have time, we can have a Q&A session afterwards where you can come up to the podium. I suspect we won't, but all of these guys are going to be around after the meeting, and all of their and there's business cards up front as well for follow-up questions. So with that, I'll get started. Oh yeah. I'll grab that. Read the question. Turn on your mic. Read the question aloud, and then answer it accordingly.
Okay, so the question I have here is, do they test for PCE in the Tahoe Keys? And by the Tahoe Keys, I want a clarification of, do they mean the lagoons? Is that the clarification? Whoever submitted the question? Is anyone? Okay, so I'll answer it in both. So on the water system, yes, as we discussed earlier, we do test for PCE. And then in the lagoons, the Tahoe Keys Water Company does not test for PCE in the water of the lagoons. That's not considered a source water for the Tahoe Keys Water Company. Whether the association decides to test for PCE, that's something that I'm not aware of. So I hope that answers the question.
All right. We've got a number of questions here. So, well, first question is, how big, wide are the test wells? The test wells that we installed were 6-inch diameter wells, and they're sized to be appropriate for the expected flow rate for those wells. So you size the well for the size of the pump that you need to fit in that well. And again, that gets back to what the expected flow rate. So for the tens of GPM wells that we installed, the 6 inches is appropriate. How much has been spent on every one so far on the PCE issue? I can just, in terms of what the district has spent in terms of the South Y investigation, I think we're probably upwards right now of over $400,000. Half of that was shared with the El Dorado County Water Agency as part of their cost share program. And again, a lot of that was leveraged for the additional $500,000 which we were just received on that Prop 1 planning grant. Rick, you want to... How much has Tahoe Keys spent on PCE so far?
I know I don't have an exact number. I know with the installation of the GAC filtration system, it came inward of $400,000, and then you have to include operation and maintenance. For instance, a media change out and a 120,000-pound vessel would be, upwards of $40,000, and that happens, every 2 to 3 years. So, and then increased sampling. Water sampling, PCE sampling costs. I would say, I don't know, if a figure maybe $600,000, something like that.
For Lukens, so far we've gotten $137,000 in planning grants for engineering and design. In addition to that, we've probably spent close to $100,000 in additional fees or additional costs related to PCE contamination. And then for purchase water, we're probably close to over $200,000, I would say, so far in purchase water, and that's ongoing. I'm sorry, when I say purchase water, that means purchasing water from South Tahoe PUD. So we have 2 emergency interties with South Tahoe PUD. We're currently utilizing one of them as supplemental water to ensure water pressures are maintained throughout the entire water system. So we have to pay for that on a quarterly basis, and that is a direct surcharge on to our customers, unfortunately.
For Lahontan, I don't have an estimate of how much we have spent. We've done the state of California has done a couple of different investigations, and we have extensive staff dedicated to this and have had so for quite some time. So, but I don't have an estimate.
Next question is, can you put in layman's terms, how deep is the plume? Well, as I tried to show in the figures, the contaminant plume at the field investigation site extends the main body of the plume, where the highest levels of contamination, extends to a depth of about 52 feet below ground surface. So it's between that interval between 26, 28 feet to 52 feet. That's where the majority of the contamination is. There are lower levels, trace levels of contamination that extend down to that major aquitard of 94 feet. And then, as you saw in the baseline sampling, with the depths of the wells that were sampled down gradient at Lucan Brothers number 5, Tahoe Keys number 2, you can see that contaminant plume extends all the way to a depth of between 140 to 180 feet below ground surface. What is the source of benzene? Don't know. So the benzene was picked up in the zone testing, but as you saw during the time series sampling during the pumping test, there were no detections of benzene. So, as far as what caused that detection, that result, that question's unanswered. So I can't tell you right now, since we don't have an answer for that. So what is the total estimated pounds of PCE? My understanding is that more than 900 pounds of PCE have been removed at the former Lake Tahoe Laundry Works site. Is that correct? So I think in a couple months, when we do the modeling simulations, we'll be able to give you better estimates of what the total contaminant mass in that plume may be. So again, can't give you a good answer right now, but maybe in a couple months we will be able to. What is done with PCE-laden water after pump out? That's a good question. What we did for the pre-design investigation, again, I showed you those white tanks. Those are granulated activated carbon vessels. So the contaminated water that was produced by those test wells was run through those carbon vessels. The PCE was removed from that water, and then it was discharged to the district sanitary sewer system. Question, how many trillions of gallons must be removed to have a noticeable effect? Well, that's a great question, and that's one of the objectives which we'll find out during the modeling simulations. So that's to be answered. Has PCE been detected in the lake? That's another very interesting question. I think, again, when we run the no-action alternative and we take a look at what the simulated movement, migration of the plume, that will help inform an answer to that. I suspect that it quite possibly, again, this is just my opinion, that it's quite possible that PCE has already reached the area of the lake. I mean, it's already gone to the Tahoe Keys number 1 well at detectable levels. But again, once you get in and where the groundwater seeps into a surface water body, you're going to have such great dilution that contamination is not at a concentration that you could detect with any type of laboratory analysis. What did you do with the contaminated water that was collected? Well, we just answered that one. And is the benzene indicated as resultant from a tropine boat? I'm not sure what the what is the second one? Or a cleaning product, or from a cleaning product. Again, I suspect most of the benzene that's been detected in the South Y area is related to petroleum hydrocarbon, gasoline use, and spills. But when you see levels on the order of 100 parts per billion, it kind of suggests a more recent spill. And but again, that was found in a zone test sample. That was a 2-hour sample that was pumped. The samples that were collected, the time series sampling, no benzene was detected. So kind of the jury's still out on whether that was a false positive or not on that first sample.
For you.
Yep.
Okay, I have 3 cards here that ask basically the same question, which is why has it taken so long to address this problem? 30 years. As from our perspective, I mean, we've been working on it for quite some time, and the way in which this works for us is that we work with the information that we have. Unlike a surface water, we can't see it. We're working underground, and so there are initial investigations that produce information. We respond to that. We did that and thought we had things under control, but then new information came in showing us that plume migration was happening or contaminant migration was happening. And I would just say it's really due to the complexity of the situation, how we're able to gather information, and then with our processes on like the cleanup and abatement order, how we need to be able to put the information together in a manner that meets the requirements of the law in order to take the action, such as like a cleanup and abatement action or order against the responsible parties tied to the former Lake Tahoe Laundry Works. I know that's not necessarily a satisfying answer, but that is basically probably the primary reason from our perspective that it's taken so long to get to make any progress on this. Another follow-up question was, why are the water companies doing this work and spending our community money to study and clean this up? Well, they're in part doing that. They're not doing that alone. There have been multiple investigations by multiple parties out there, including multiple different sources, Lake Tahoe former Laundry Works facility being one of them, a couple of other dry cleaner facilities, former dry cleaner facilities, some automotive. So there's been work by private, plus by the water districts, plus by the state. So it has been I'll say a group effort on this. The water districts can speak to themselves, but I would say in part the reason they're doing this is to continue to provide a safe drinking water supply and to be able to manage their systems in a way and to eventually modify their systems in a way that continues to provide that safe drinking or safe water supply. Okay. Another question is, why haven't the responsible parties started remediation? Actually, there is active remediation that's been in place since 2010 at the former Laundry Works site. There have been some interruptions, but they have been doing active remediation there, more or less to try and direct it at the site itself. And then, as I said, with our cleanup and abatement order, we're looking to have them explore or investigate and actually delineate or identify the full lateral extent and vertical extent of any contamination that has left that site. And once we have that kind of information, then we can determine their responsibility in further remediation if that's what the data shows. So that's where we're at right now, is further exploring how far out did their contamination migrate from the site. So, but since 2010, there's been active treatment there. There's also been another site where contaminated soil was removed, so source removal. There has been work done out within the area of contamination, but we still have, as it's been explained, significant contamination still out there. And it was mentioned also the extent at which the former Laundry Works has removed PCE, upwards of 900 pounds since they've been operating. So, and as Ivo said, looking at the field testing that they did, that's quite a bit. When, would you say 100 days for 3 pounds? So to get 900 pounds, that's a substantial amount. What volume of PCE was spilled at the contaminant location? For example, the dry cleaner. And when precisely was the PCE spilled? I do not have a mass or a total volume. It's at multiple sites. That there's more than one site that we know of where there's been spills, and it was over a time period, starting back in, I don't know if it goes back into the 70s, I believe so, and continued on until it was discovered and taken care of. So it's over a matter of years, intermittent spills, and discharge practices that have led to this contamination. What is the time frame for remediation? Well, as I said, some is already occurring. I think looking at the feasibility study that the district is doing here will also lend some information to that on when will additional remediation possibly start. The investigation that we have the responsible parties at former Laundry Works site doing, that could lead to additional remediation, but that time frame, I would be guessing at this point, but I would hope within another, say, couple of years, if the data shows that they have a responsibility out there to do additional remediation. As we continue to get our funding to do additional investigation, identify additional sources, and also we are planning on, as I said in my introductory comments, plan on increasing our efforts to help secure funding for the water districts and for the community to address this problem. We're looking to get some kind of treatment going, remediation going. That would be part of our efforts to help facilitate the community addressing this problem. But I don't have a specific time frame, unfortunately. And that wraps up my questions.
One question that wasn't answered.
Oh.
The card. How much success?
Oh.
Yeah.
Sorry. How much success has any other location realized in abating PCE plume?
Right.
The one that I'm aware of is the former Laundry Works facility where it's been reported 900 pounds. I'm not aware of any other amount being removed from the groundwater itself. As I mentioned, there was contaminated soil removed at another site. But with respect to this PCE plume, I can report to the 900 pounds from the former Laundry Works site.
I think It's 7:30, and I said that that was going to be the end time. So I'm going to wrap it up and have these guys stay up here for more questions. Individually, you can come up and talk to them. Thank you all for coming and asking questions and getting informed. We will be having another public meeting come fall. We'll advertise in the local papers and radio and local TV station as well to try to get the word out so that we can keep everyone informed on where we're at and what the water districts have found out and the state board as well. So thank you again for coming, and these guys will be available until the wee hours to answer more questions.
Thank you.
Head out of here.
You staying with us?
Oh, let me collect your